Now, let's solve a question. Maybe in the end of this question, we are going to give a break. Now, we have a joint probability density function of two continuous random variables, x and y. In fact, I do not need to indicate that these are continuous because it says joint density. Okay, it does not say joint mass function. It says joint density function, therefore these two random variables are continuous. And the joint probability density function is 2 minus x minus y. And x values are, the random variable x is taking values between 0 and 1, and the random variable y is also taking values between 0 and 1. Now, actually yesterday, in the last part of our course, we have stated that under this density function, the two random variables are not independent. They are dependent on each other. So we have checked that. Therefore, we can ask conditional probability questions on this density function because they are dependent. Now it says, compute the conditional probability density function of x given that y is equal to 0.75. Okay, so basically asking this question. I have observed that the random variable y is equal to 0.75. Okay, I have observed that the random variable y is equal to 0.75. I would like to ask a question, a probability question on random variable x under this observation. Now, in order to answer such a probability question, first we need to determine the conditional probability density function of x under the observation of y to be equal to 0.75. And according to our formulation here, the conditional PDF of x on y requires the marginal PDF of y to calculate. So let us calculate the marginal PDF of y. Now, if you remember from yesterday, in order to compute the marginal PDF of y, I need to integrate the joint PDF over all possible values of x with x operator. Okay, I am basically squeezing the joint PDF over x-axis. Now I need to integrate, because the possible values of x is from 0 to 1, I need to integrate the joint PDF with respect to x, and I'm not going to explain the integral anymore. That is going to be 3 over 2 minus y for values between 0 and 1, and that is the joint PDF of y. I'm sorry, marginal PDF of y. Now, the conditional PDF of x, given that y is observed to be equal to 0.75, is what? We are going to compute the ratio of the joint PDF. So we are going to divide the joint PDF to the marginal PDF of y. However, since we have observed y to be equal to 0.75, we are going to plug in 0.75 at every y value that we observe here. And when you plug in 0.75 in these functions, you are going to get 5 minus 4x over 3. 5 minus 4x over 3. And that is the conditional probability density function of x when you observe y to be equal to 0.75.